Hello, my name is Werner, and today I have a short video about modifying your TBLE 02S Tamiya speed controller that comes with many of the modern kits to have a low voltage cutoff that is suitable for LiPo batteries. I made a blog post a while ago, and recently somebody asked for a step-by-step instruction, and I hope this video provides that. In order to perform this modification, you will need the following items: a soldering iron and some solder, a hobby knife, tweezers, some magnification, a flat screwdriver, a 33 kilo ohm resistor. I'm using an SMD resistor because it's very small and the size is called 0805. I provide links in the video description where you can purchase these resistors online. And you also need a tiny piece of wire. The one I'm using is 17mm long. I'm using enamel coated wire, but you can also use a very thin plastic insulated wire, 30 AWG or something like that. Before we start, let me give you a quick overview of the task that we're going to perform. In this picture you see the circuit board underside of the Tamiya speed controller. On the bottom you see a kind of a test point labeled G. This is a ground plane and we're going to use that to mount our resistor with a drop of solder. The resistors circled here are forming a voltage divider that is used by the microcontroller to sense the voltage of the battery. What we're going to do is we're going to modify the resistor divider value so that it allows for a higher cutoff voltage than the default 4.9 volts. The 33 kilo ohm resistor we're going to use will have a voltage cutoff of 6 volts. In order to connect to the voltage divider, we're going to use the trace that is just underneath the resistor and above the label C9, where we're going to scrape off the coating and the green solder mask to access the bare copper. And this is where we're going to mount the wire, which then connects to the other side of the resistor. So now with that we're ready to go. Let's start. So first we need to open up the speed controller. This is quite easy to do. All we need is a flat screwdriver. On the side of the case you see these two catches, and you simply gently push inside and the case springs right open. After you've done one side, you flip the case over and just lift away the bottom, exposing the circuit board. The circuit board is just held in with the bottom, so it is now loose and free to come out. You cannot get it out all the way because the connectors soldered to the main cables cannot go through the hole in the case. It's important to remove this pin that is for the push button. Keep it safe and make sure that before you assemble it you put it back, otherwise you cannot adjust your speed control anymore. I'm now using blue tack to secure the speed controller onto the table to have a steady workplace. The heatsink pushes into the blue tack. The first thing you do is to gently scrape off the conformal coating, which is a kind of a dust and water protection, from the ground pin. As you can see, it gets shiny the more I scrape. You have to be very careful here. You don't want to scrape too much, you don't want to damage the copper itself. Just get rid of the coating. Now we're moving to the area of the trace just below the voltage divider resistor, and here again very gently first you scrape away the coating and then the green solder mask. You can see now it starts shining through in this copper color. Having done this, we can now tin the areas so that it accepts the component and the wire. The ground plane is very easy because that was already bare copper. The side with the voltage divider is a bit more tricky because there may still be fragments from the solder mask, which by design prevents solder to stick to it. But if you have scraped well, then the solder will eventually stick like now, and we have the small in place. So first we put on our tiny resistor, We use our tweezers to pick it up with the left hand. Gently position it over the solder point. Of course, only one side of the resistor touches the solder. Small dab with the solder iron, and the resistor is secured. The other side of the resistor is over the green solder mask, which provides an insulating layer towards the copper underneath, so there's no risk of shorting anything. I pre-tin the other side of the resistor so it can receive the wire. The wire is already stripped and pre-tinned, and I'm picking it up with the tweezers and moving it over the position. I started the voltage divider because it's the more critical joint. After a quick check, I found that my stripping was a bit too wide, so I'm using my side cutters to trim off so that I only have a little bit of stripped wire and the rest is insulated. With this modification, I can now put the wire in place. So here I have a small mistake. I'm actually soldering on a nearby test pad, but I recognize my mistake, and now I'm moving to the actual pad that I need to solder on. It's very tiny and flimsy. So now I'm tugging a little bit on it to see that the wire is secure, and when it's not coming off, that means it has been soldered correctly. I very gently bend it now so that it can move to the other side of the resistor. It's not quite good enough, so I have to tweak it a little bit. That's better. The wire is now in parallel with the resistor pin. I hold it in place and solder it down. And that's basically it. The modification is done. Now at this point it's very important to perform a visual inspection to see that no stray solder has caused any short circuits, that nothing is touching where it shouldn't touch, and everything is clean and tidy. So we can put back the speed controller. First we put in the plastic piece for the push button. Then the circuit board can go back in. Usually the motor wires also have a connector, which I already removed. But if you have the connect in place, you don't have to fiddle around like I have to do now to get the wires back in. Once the wires are through and the switch is on the correct side, the circuit board very easily slides into place. If it's not easy, you're doing something wrong. The circuit board is in now. I address this wire to this receiver and this wire to the switch. I take the bottom case and notice the two cutouts for the wires, which have to be on the one side, and simply click the bottom plate into place and make sure the catches click. And that's it. Everything correct, and you can test and use your speed controller now safely with LiPo batteries. So I hope this was helpful. Thanks for watching. Please subscribe and like. Thank you.